Okay, so this is the second half of a test, calling it lesson 14. Again, trying to put all the questions in front of you. And let's see if I can capture this. I gotta put it further back. So Renee, we're being put out to pasture for a minute. That. There, now we can see everything. Apologize for these streaks. I don't know how to deal with that. I'll put this one over here. So 56 is equal to 12. I know you're not gonna be able to see that. All right, that's a 19, so 2000 gets you 19. That's hard to see as well. So anyway, we'll have at it. Those are the only places that I see the streak of light. Okay, and then I've got the answers to the first problems 44 to 59 here, and then 60 to 70 are graphs. So these are all sketches, and that's I think the nuts and bolts of the worksheet is trying to make some real gains here so that you can quickly graph. And what's the goal in all of this? To do these problems and to say, that's easy. That's the goal. When you look at it and you go, that's easy. I feel like I've done my job. Until then, I don't feel like I have. The same thing with the graphs, but again, pay attention. Pay attention to m times 0 plus c and m times 1 plus c. We're using that significantly in all of these situations, creating zeros and ones and working with zeros and ones. And how do we get a 0 from a log? We make the parentheses 1. Doesn't matter what the base is. How do we get a 1? Whatever the base is, we make the parentheses the base. We can create zeros and ones, and those are the easiest numbers to multiply and add a constant. And if you look over here at the graphs, there's an awful lot of multiplication and adding constants, so on and so forth. So we want to be able to get good at that. Getting a little noisy in the hall, so I'll shut the door. All right, so if you take a screenshot, these are the questions that I'm asking. Approximate the sign of 3. That ought to throw you. And the rest looks like there's nothing else we haven't done in previous lesson sets. So here's the answers I just put on the board. There we go. And then got these answers. Let's see if I can move Renee back enough so you can see everything. That's good. Okay, and those are the answers that I got to the problems that I just showed you a minute ago. All right, so I'm going to have at it. Okay, so exponential function, I see y equals 2. We're going to graph this, I guess. Write the equation. So it's just writing the equation. It'll help us to graph it. I see to 17, I got to go up 15 from 2. 47, I got to go up 45. And I see a 3-to-1 ratio of differentials creating that exponential function. So I see that, and so I can just write this now. I can say y equals 2. My first jump is 15. My next jump is 3 times that. Make a 0 out of 1990, x minus 1990. And I've changed from 1990 to 2024, 34 years. You should always plug in the second x value as a quick check. So that gives me 34. So the 34s cancel. 3 times 15, 45 plus 2, 47. Move on. All right, so we're just gonna, I think I said cheat the process in the last video, and then I made a mistake adding and subtracting. So if you put 3 in, 9 and 11 is 20 minus 21, you get -1. If my remainder over here isn't -1, I've made a mistake. Because if a 3 gets you -1 over there, a 3 has to get you -1 here too. So I can see x minus 4 gets me the first two numbers quickly. And now I can see -3 times -4 is +12. How do I get from +12 to 11? I got to go down 1, and I'm dividing by x minus 3. Okay, if you do x minus 3 times x minus 4, you get x squared minus 7x plus 12. If I erase this now, because that's what I get, I hope you can see the x minus 3's cancel. We get -1, which takes us to 11. That's, for me, this is the precursor to long division in Algebra 1, which people do and generally don't know what they're doing and why. So, I could have asked the question, x squared minus 7x plus 11 divided by x minus 3. Same answer, whatever it was here in this parenthesis, same answer. All right, planting some seeds, hopefully. All right, so I'm hoping you can do this in your head, but the steps that you would take would be add 3, divide by 8, 5 to the. Okay, the inverse of log base 5 is 5 to the. In this case, the is a 1. Multiply by 4. Add 2. Check your answer. 22 minus 2, 20. 20 divided by 4, 5. What do you put on top of 5 to get a 5? 1. What's 1 times 8? 8. What's 8 minus 3? 5. Move on. Okay, I'm hoping you can just look at this and write your answers, 3 plus or minus. The answers are real. I can get an intersection with 0. 0 is below 19, so I have real answers. There they are. How do I get that? Put it in graphing form. Minus 2 times x minus 3 squared plus 19. When does that equal 0? Minus 19. 19 over 2. Plus minus the square root of 19 over 2. 3. Plus minus the square root of 19 over 2, which we knew without any effort because we put the effort in to look here, look at the original problem and go, do I really need to do any work? No. Show that answer. Let's not show that answer because I just erased the graphic. X squared plus 8x minus 50. You can think about multiples of 50 and whatnot, but an even number, why not just complete the square? X plus 4 squared minus 16 minus 50 equals 0. And then I can see my answers. X equals negative 4 plus minus, right? Positive 4, negative 4. Minus 66 becomes positive 66 square root, and I'm done. We'll show our answer here. Minus 4 plus minus the square root of 66. Let's do the math. Get rid of the 4s. Get rid of the plus minus. When you square, you get a positive. When you square a square root, you get what's inside. And 66 minus 66 happens to be 0. That one's done. All right, so I can look at this and say negative 12. All right, this is asking the question, m to the what equals m to the 3 over m to the 9 to the 2. I know m to the 3 over m to the 9 is m to the minus 6. And I know my rules for exponents multiplication, and I am losing this marker. Bear with me. Hope that one of these two has good ink. We're up and running. Black and blue. Okay. So now, what's this one? Well, looking at it, I'm seeing I want minus 8, and I don't want the 7th power. All right, so what did I do? I asked the question, m to the 7th to the what equals? Well, m to the 3 times m is m to the 4. That's what's in the parentheses to the negative 2. Well, I think I can see 7x equals negative 8. I guess that answer is correct. That's the exponential activity that I need to turn m to the 7th into m to the minus 8. I hope you can see it. Boom. Okay. That's that problem. All right. This one will take a little explanation, not for the first part. That's equal to 1 over x cubed. But we have to multiply by m to the minus 4 divided by m to the minus 1. Let's rewrite it. That's 1 over m to the 4 divided by 1 over m. Well, if I'm not mistaken, division by a fraction is multiplication by its reciprocal. And here's the kicker. M to the minus 4 ended up in the denominator as a positive 4. M to the minus 1 ends up in the numerator as a positive M to the 1. I guess I can move this one here. It's gone. And I can move that one there. Well, that's also 1 over M to the 3. So let's put it right there. Have a little difficult time writing the 3. There's that answer. And if you don't get it today, remember the rule of 4. 4 days of practice, 20 seconds a day. 4 days from now, if we're doing it in class and we're doing it on every test, then it should become hot knife through butter. There we go. I'm getting better at erasing. I learned from my last lesson set not to erase the next problem. That's really good for me. I see an absolute value, V shape, -9. I'll make a 0. And I want to get 10, so I'll write 10, and I got my Y value when I plug in -9. I need another value here. Why don't I have it? I forgot to write it. Okay, what do I have for an answer over there? And then I'll recreate it. What number is it? 52. Let's get, so it was 0, -1. Was it 0? No, it wasn't 0. It was 13, right? So 5. So it's 5, -1. There. Do I have that now? No, that was a negative. So it's -5, -1. There we go. I think I finally got back to what it should have been. So how do I get from 10 to -1? I go down 11. And I knew it was a negative anyway because it's V-shaped down. And -9 to -5 is 4. And that's that equation. What's the sign of 3 approximately? 1.14. Okay. This is a difficult concept. What a radian measurement is. So if we have a circle, that was a pretty good one for the rotator cuff. We have a radius. We're going to say that's 1 unit of measurement. If I measure and start from here, that distance takes me to about there. 2 of them takes me to about there. 3 of them, let me erase this now. 3 of those distances take me to about here. And I know 3.14 takes me there. Okay. So if I draw the triangle, you estimate that height. Sure looks like it's almost identical in terms of distance from there to there, from this place to this place, which is called displacement. I can't pass up the opportunity to say that. All right, so 0.14. And that may be right now going over the head because we haven't even done the unit circle. That's coming tomorrow, right? That's a homework assignment. So everybody else keeping up with the lesson set, I'm not going to give a lecture on that. I'll talk about it as we go through future lesson sets, but the lecture is there. And if you want to keep pace with the language of trigonometry, I strongly suggest you look at it. All right, so that takes care of that one. Oh, I didn't do such a good job there. 9, 8, boom, finding Y, and then finding the sine of angle A, which is over here. A is going to be drawn in standard position, first, second, third, and fourth quadrant, always. So what do we have? 81, 64. What's that, 17? So this Y value is the square root of 17. So opposite over hypotenuse is square root of 17 over 9. And that's what that command is. That sign means look at the opposite side, compare it to the hypotenuse for the angle situated right here. Well, that's the opposite side, and opposite 90 degrees, I should have put a 90 there, is the hypotenuse. Okay, and you got to have your definitions down, or you're going to have a lot of trouble with that calculation. 5e to the x is 30, therefore e to the x is 6. Therefore, on a calculator, I push the button ln of 6, and it gives me approximately 0.7, 1.1, 1.8. Why? Because 2 times 3 is 6, and 2 is e to the 0.7 approximately, e to the 1.1 for 3, and that's e to the 0.7 plus 1.1, and we're headed towards the rules of logarithms, which are really about the rules of exponentiation. Okay, so this is equal to 12. Well, that blind spot is off the board now. So I'm gonna divide by 3. By 4, I'm gonna divide by 4 to get 3. I'm gonna do the inverse of ln, which is e to the 3, and then I'm gonna add 5. Let's see our answer work. 4 ln of x minus 5, 4 ln of my answer, e to the 3 plus 5 minus 5. Let's see if that equals 12. Well, the 5's cancel, and I got ln of e to the 3. Let's think about that. The ln of e to the 3. The ln of e to the 3 is asking the question, what do I put on top of e to get e to the 3? What do I put on top of e to get? Whoa, those are inverse operations. I guess it's a 3 times 4 is 12. All right, we just did the ln of 6. Maybe you can do the ln of 24. The ln of 24 is 2 cubed times 8. If we want to get it, organically, right? I have asked my students to memorize e to the 0.7 is approximately 2, e to the 1.1 is approximately 3, e to the negative 0.7 is approximately 1/2, e to the negative 1.1, 1/3, and e to the 0 absolutely is equal to 1. Got to know those values. And I think I even did e to the 1.6 is approximately 5, the number 5 on a calculator. So I've got 2's and 3's. I can change it to e notation. Okay, so 2 to the 3 is e to the point. Wait a minute, that's not 24, excuse me. 2 to the 3 is 8. And 8 times 3 is this number. So I had to backtrack, my apologies. 2 is e to the 0.7, and I'm cubing that. And 3 is approximately e to the 1.1. So what are the rules of exponents? I think I have e to the 3 times 0.7 plus 1.1, which is 2.1, and 1.1 is 3.2. So the answer to this was approximately 3.2. If you put 2.71 in a calculator and raise it to the 3.2, you're approximately at 24. Now, what is 3.2? Well, it's 32 divided by 10. So the calculator is taking the 10th root of e, and then, I forgot what I said, raising it to the 32nd power. Woo! Wow. What did I just do? I don't know what I just did. Yasser, come help me out. I forgot what I was eating. I forgot where I am right now. All right, so I'm looking for the exponent on top of e that gives you 24. And I'm not sure what I just did there. I'm gonna keep going, have a laugh. Gotta be able to laugh at yourself. All right, especially when you get to be my age. Sine of 4 pi over 3, you're gonna learn how to do this. You're gonna break. Okay, I gotta start again. I don't need the XY axis for you right now. I need top half of the circle is pi radians, 3.14 radius lengths. I'm going to break it up into 3 parts and try to do a nice drawing. Good drawings get good answers. I'm going to write it. Good drawings. Going to be working with this. Get good answers. Okay. Obviously, I need the second half of the circle because I got to get to 4 pi over 3, which is here. That's a good drawing. So that's my triangle. Now I can draw an axis. It looks something like this. And that's to 1. This is negative 1/2. This is negative 1. And I'm here. Okay, so that means I know the width is minus 1/2, and I know the height is minus √3 over 2. My reference angle is 60 degrees. This is a 240-degree angle. It's the same thing as saying the sine of 240 degrees. All right, and we haven't done the unit circle yet, but this is what we're going to start practicing. And this is negative √3 over 2, and this is 1. The hypotenuse is always 1. Remember, it doesn't matter if we have negative numbers here. Doesn't matter. This is minus 1/2. Does not matter, because when you square, you get a positive area. You square, you get a positive area, and that has to add up to a positive area. So the hypotenuse is always 1 in the unit circle. All right, now I've asked students to look at the introduction to the unit circle. the intro to the unit circle. That's a video you gotta watch because I'm not gonna take 20 minutes of time. We already got one snow day. We might have another. And there are certain things I want to make sure that you can do before this class is over. We should be able to get there with ease. But at the same time, you got to do a little work. Okay, so I'm going to leave that to you. It's explained elsewhere. So go to the YouTube channel, go to trigonometry and look for introduction to the YouTube channel, introduction to the unit circle. All right, so we want to name this too. All right, so I see 3 to 11. I like the number 8 in this lesson set. I have no idea why. My second differential is not 8. 3 to 19 is 16. So I got a doubling function. I'm starting with 3. I'm adding 8. I'm doubling it to get 16 as a differential. 1920. I'll use T this time. 1920. Very good year. A lot of friends back then. 1920 to 2000. 80 years of change. That's that function. And now we're just going to do some quick graphing. Hope I kept the camera in a place where everybody could see. I think I did. Let's bring Rennie over here a little bit. All right, and we're going to tackle these graphs. And you're looking for m times 0 plus c and m times 1 plus c. We're going to use that a lot. So what makes a 0 here? 0. So I'm hoping you can see 0 gets you -5. That's a point on a curve. It's the y-intercept. And I hope you're recognizing mx plus b. I have to imagine you are. Seems like it gets drilled into people at the Algebra 1 level. The expense of not looking at the other calculations. Right. I'm going to change by 3. I'm going to go up 2, and I look for 3, -3, which is really up 2 over 3, a little bit further there, and that should be the coordinate 3, -3. And there's your line. Milo would tell you to put arrows here. You always reminded me in class. Thank you, Milo. I'm better at that now because of you. Okay. That's problem 1. That's gone. Now we're graphing this quadratic. Why don't I blow it up a little bit? Now, if I was doing this, I know I have cup shape up. I know my y-intercept. Oops, sorry, Milo. I know I'm on the downside for 0, +7. Confirming it, 20 divided by 10, which is minus b over 2a, right? Gets me a 2. Oh, yes, zeros to the left of 2. Dropping in a 2, cutting it in half, gets me -20 plus 7, -13, and I'm done. And I know that 4 also gets me 7 because of the symmetry. Let's check if 4 gets us a 7, because we haven't done that too often. So 4, 16 times 5, 80. 4 times -20, -80, plus 7. By golly, 4 got us a 7. Wow, just the same way as 0 got us a 7. How nice. Now I look at, that one's done. So the next one is y equals x minus 4 times x minus 8. Be nice if you could graph this quickly and recognize that if you put a 4 in, you get a 0. And if you put an 8 in, you get a 0. And it's cup shape up. Geez, I wonder what the vertex is. I wonder what the number is between 4 and 8. Oh, I guess it's 6. And that's going to get me a fictitious square. 2 times -2. -4. I guess I've graphed it. Pretty soon, we're going to be not only solving these things for 0, but we're going to be talking about inequalities. When's it greater than 0, etc., etc. Of course, I just did it for you. The answer to that would be -infinity to 4, union 8 to infinity. Because the stuff in the middle is negative for y values. Right? Negative. Negative's not bigger than 0. But these branches are. Now, in grade school, you would have probably said x is less than 4 or x is greater than 8. You might have even done an open circle this way and an open circle that way. And if I wanted it to equal, then you close the circle and you put an equal sign there, and in interval notation, you make a bracket. So I just planted a little seed for future reference. And 2 sine x plus 1. The easiest way for you to see this right now, how to graph y equals 2 times the sine of x plus 1, is the sine of pi over 2 we've been working with for a little while, even though we haven't done the unit circle. We know the circumference of a circle is c equals 2 pi r, and if r is 1, then I now have 2 pi units all the way around, which translates to 360. And if I start here at 0 degrees, straight up is 90. And 90 degrees in radian measurements is pi over 2. And the sine function, if we've been looking at the sine function, drawing triangles with a hypotenuse of 1, the sine function is all about height. And so what's the height in a unit circle? 1. Right? So I can do that. I could say, well, let's just do one period. Let's go from 1 to -1. And let's start here and go to there. That's one period. Then I start doing the same drawing over and over again. And I now know that pi over 2, the sine of pi over 2 is 1. 1 times 2 is 2, plus 1 is 3. Planting seeds here. And when I come back to 2 pi over 2 plus 2 pi, one trip around the circle. One trip around the circle, starting here. Oh, not starting here. Starting at pi over 2. I'm back to 1. But in this case, I'm doubling that 1 and adding 1, which brings me to 3. So that brings me back to 3. Okay. Now, if I know that, then I kind of know the symmetry of this, right? That's halfway between this and this. So what's halfway from pi over 2 to 2 pi? Pi over 2 plus pi. And that means I'm at the bottom of the circle, which is -1, -2 plus 1, -1. So I go from -1 to 3, and we haven't really talked about the range too much, but the range of this calculation, the range are y values that are less than or equal to 3, but greater than or equal to -1. Boom, 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 boom. Oh, Yasser, I saw that clip. I didn't realize you gave me a URL. I clicked on it and had a good laugh. So that was fun. All right, so now what's next? We're getting there. We're getting there. I think I did that one out of sequence. That was actually number 69. My apologies. I should be over here at 62. We did that. All right, so I see an absolute value. We're graphing y equals -3, absolute value of x minus 6 plus 15. I see a V shape down. I see a slope of 3 to 1, going down at 3 to 1 on this side, up to 3 to 1 on that side. I see a vertex of 615. I'll throw a 0 in. The 0's on this side. I like frame of reference. That gets me -18 plus 15 minus 3. I'll check my 3 to 1 slope. 15 to 3 is 18 units of change. 6 to 0, 6 unit. Yeah, I got plus minus. I'm good. And if 0 gets me -3, then it looks to me like 12 should get me -3. Let's put a 12 in. That gets me 6. And let's do the math. Oh yeah, -18 plus 15. Yeah, doesn't hurt to confirm things. I make careless errors now more than I ever did before. All right, so that's 63. 64. Oh, I got to make sure we look at the 0s and 1s here. And I haven't been doing that. Bad mistake. Okay. All right. So what happens if I put -5 in? -5 gets me m times 0 plus 17. I think I get 17. And then we draw the square root trajectory in the wrong direction because it's negative. So we backtrack, we start again.
we make a -5 and a 17. That's why I like the whiteboard. All right, so there we go. It's a negative. All right, going down. How do we make a 1 out of this? Well, we could do -4. -4 plus 5. 1, square root of 1 is 1. And then I get multiplication by 1 plus 17. So that's an easy point to get. -4 gets me -2 plus 17, -15. A positive 15, sorry. Oh yeah, should write it there. I'm going down. Yeah. And if I wanted another place here, just someplace in the distant future, I throw a 20 in, just to see what I get. 20 plus 5 is 25. Square root of 25 is 5 times -2. -10 plus 17 is 7. Yep, 17, 15, 7. Nice trajectory. Yeah. And if I didn't have this, let's look at the 0 ones from that capacity. So I put in that part, but how did I get -2? Well, let's put 20 in, and I get the square root of 25. And guess what the square root of 25 divided by the square root if I put 20 in? They cancel and they become a 1. And then that gives me 17 to 7, -10. Right? And what's -10 divided by 5? -2. So somewhere in all of what I just said is the process. I'm hoping you're saying for some of these, you're going, oh, that's easy. Let's hope so. So 5, 4, exponential. That means I already know that I have a y equals here, and I'm jumping 5, and then I'm jumping 4 times that, 20. I already know that. Exponential growth, right? And now what do I have for a constant? +3, so that means I can put a 3 here. 3 plus 5, I know I got an 8. Like 8's in this lesson, so we don't usually use it. 3 plus 20 is 23. If I can find the right values that go with the exponential part of -59, oh, I think that's 59, changed by 70, that's 129. I think I'm done. Plug in the second number, 129 minus 59, I'm hoping is 70. Got Yasser to back me up. 4 to the 1, 4 or 5, 23, done. These graphs can get down to 10 seconds or less, every single one. Okay, now we have y equals 5 log base, where am I, 4 x plus 2 plus 14. Can you see 5 times 0 plus 14? Time to ponder. Well, the only way I can make a log 0 is if the parentheses is 1. I don't care what the base is, b to the 0, that 0 goes here, gets me 1. All right, so I can see -1 gets me that 14. In other words, once I get the 1 here, I don't even look here anymore. I just look there. -1 gets me 14. Then the next thing is 5 times 1 plus 14. That's what we want. So how do I make log base 4 x plus 2 turn into a 1? Well, I hope you say when x is 2. Right? 4. So I spot that. I already lost my first problem here. So we had a -1, we spotted that, getting us 14. And now I'm seeing a 2 gets me 5 times 1 plus 14, 19. Those numbers should appear. Now, what's the other log that's important? Log 0. That's really important here. That's probably the most important log, is to know that that's undefined. There's no solution to that. Right? You cannot take a positive base, and b is defined to be greater than 0. You cannot take a positive number. Let's take any positive number, 2, raise it to an exponent, and if you get a 0, you get an A+ in the class, and I stop and I go out the door and I'm fully retired. So what makes a 0? -2. All right, I can get those back easily. So -2. Didn't do that very well. And I know I have a 1-to-4 ratio, which means that's going to be 1/4. That's going to be 1/8, so on and so forth. And I'm going to get something that looks like that. All right, so let me doctor it up. So x equals -2. I put in a -1, I get 14. I put in a 2, I get 19. What I'm suggesting is from -2 to 2 is 4 units of change. From -2 to -1 is 1 unit of change, and that's this base, 4 to 1. Which means my next one's got to be 16 units of change. And that's going to happen, I think, in 3 units. I think it's 5, but let's find out. Nope, I made a mistake. It's 16 minus 2, 14. 14 should be a very friendly number. Oh, it is. 14 plus 2 is 16. What do you put on top of a 4 to get a 16? 2 times 5 is 10, plus 14 is 24. But I think I made a boo-boo somewhere. So that's a change of 5. Right? Another change of 5 is 24. This is 1 and this is 4. Oh, that should have been, yeah, 4 times that. Should be 16 minus 2 is 14. Yeah, 14 gets us 24. Okay, so my conjecture is correct. And if we're moving in the other direction, then that's 1/4, then 1/16. I hope you can start to see the asymptotic behavior here. Right? It'd be nicer if I gave you a little space there. That's 1/4. Right? I'm going in the other direction. And, 1/4 to the right of -2 is pretty. The x values aren't changing much, but the y's are changing a lot, and that's asymptotic behavior. Or it's patternable behavior. Okay, so where am I? I'm at 3e to the x plus 2. So next one we're going to graph is 3e to the x plus 2. Okay, so whatever the first jump is 3. I'm going to triple it. Let me get a little lower here. Whatever the first jump is, that's your first jump is 3. I'm going to triple it. I'm going to make it 9. Approximately. So y equals 2. Okay, I'm going to get to 5 if I pick the right number. I'm going to get to 11 if I pick the right number. And it's going to look like that. Exponential growth, because e is 2.71. It's bigger than 1. So I'm going to let this equal 0. What's e to the 0? There's our 1. And what's e to the 1.1? That's my triplet. I'm sorry I got the same number in 2 places. I don't like doing that early on. So what makes this 0? Just 0. What makes this 1.1? 1.1. That looks like 11 there, but 1.1. Let's check it out. 1.1. 3 times 3, 9 plus 2. Approximately 11. But it gives us a feel for the graph. All right, just about done. Just about done. But this is an opportunity to learn the math. Got to put the effort in, got to do the problems. Okay, ln of x minus 6. Y equals the ln of x minus 6. So I'm going to do one of these, except that I'm going to do the inverse. And the inverse, this base, I'm going to turn it into a base 3 problem, is going to be a 1 to 3. A 1 to 3 ratio, if I pick the right numbers. And then that would be 1/3, so on and so forth. And I'm starting at 6. I need numbers bigger than 6 for this calculation to work. So I want the ln of 1 next. Guess I'm picking 7. The ln of 1 is 0. And so 0, where's my function here? Oh, there is no constant. So 7 gets me a 0, which is 1 unit from. Oh, okay. 7 gets me 0, and there's my 1 unit of change from x equals 6. X equals 6 to x equals 7 is x equals 1 for a change. Yeah. And then I'm going to pick the ln of 3, which is approximately 1.1. This is asking the question, e to the what gets me 3. And so I push the button on a calculator, it's pretty close to that number, so we work with it. And so therefore I pick a 9. 9 minus 6 is 3, so that gets me 1.1. And now I can see my graph. And that's that log. One more problem to do, because I did that one out of turn. So let's get this one. I'll do it 2 ways. Okay, so I'm giving you a max here, 1903. Very good year, lots of friends then. Yep, very good year. 1, 2, 3 and down, 1, 2, 3 and down. So there's my min at 2000 comma 10. All right, so to prep this work, the cosine function measures width. The width is a max over here at 1 at 0 degrees or no. I'm not going around the circle at all. No radius lengths puts me there. That's a max. The sine function measures height. Boom, the height in the unit circle occurs at pi over 2 for a max. So I'm going to do this function 2 ways. Once as a sine function, which I think is easier for students to pick up. And then textbook would definitely have you do it as a cosine function because the cosine of 0 is 1, which is a max, and the sine of pi over 2 is 1, which is a max. How does this function different than every other? It's called a 2-step function because I got to turn this into pi over 2. And then I've got 1 pi, 2 pi, 1 revolution, 1 pi, 2, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. I've got to turn 2000 into pi over 2 plus 7 pi. I've got to make that happen. And if I snip this and unwind it, I get an axis, and that is going to be our x-axis, and it's going to have all of these things on it. Pi over 2 is going to match up with 1903, and 7 pi plus pi over 2, which is 15 pi over 2, is going to match up with 2000. And correct me if I'm wrong, but I think I just drew a line. So I have to come up with a linear function that connects 1903 to pi over 2 and 2000 to 15 pi over 2. And we've gotten good at writing the equation of a line. Now, that's for the sine function. This is for the sine function. For the cosine function, remember the cosine maxed, I got rid of the drawing, maxed over here at 0 radian lengths. All right, I have a width of 1. I can't draw the triangle. I can draw one near it, and you can see that width is just a little shorter, right? So I have to make 19/3 match up with 0 and 2000 match up with 7 pi. That is easier to write, but it's harder to think of this max. It's easier to think of vertical as a max. That's what I found. So what are the 2 equations? And I hope you can see the linear equations. I'll write the linear equation here first. What do I see? I see a change of 7 pi. It takes 97 years. I make a 0 out of 1903. And I put pi over 2 there so that 1903 matches with pi over 2. I do the sine function. I look at the middle because that's the most important y value, the one between 10 and 18. I see it's 14, so I know that I'm going up and down 4 units. Up and down 4 units, that's the amplification from 14. That's that function. If I want to write it as a cosine, I match 1903 to 0. I'll write the 0. I don't really need to, but I'll write it. I'm traveling 7 pi radius lengths, which takes me 2.5, 3.5 times around the circle in 97 years. And it's a cosine function. Same thing here. So how do the cosine and sine function differ? Organically, I hope you can see by 90 degrees. And each time we talk about these things, hopefully by May 15th, we're just doing them like that. And we say, that's easy. Take some effort to get there. Take some thinking on your part to get there. And I hope you're trying to do that. Okay, so yes, another lengthy video, but at some point, if you really got down to it, you could do these 70 problems probably in 20 minutes. Good luck. All right. End that meeting.